Dear students, until now we have discussed some very important terms or concepts or basic concepts in computer science under the field of operating system. And this is our second module that will be telling you more about basics of operating system. So we have discussed that there are multiple users, there is a time sharing, there is a multi-programming, there is a multitasking. So all of such tasks were done automatically by the CPU. So CPU was servicing users and their jobs automatically by sharing some small time interval and by performing multi-programming and multitasking. So this means that now there is no need for the operator who was the overall in charge for taking jobs from the users and then performing those jobs within the CPU or computer. So this means after such breakthroughs or after such implementations or after such installations, now it has become very viable that we can replace such kind of human computer operator with someone else. So that was the automatic system. And such very small chunks of implementations were basically becoming the core of operating system, which were taking the responsibility of that computer operator. So operator was not no more needed to communicate between user and computer, and today's PCs are on sole discretion of user. So today you can see that if you want to execute a job from a computer, then you don't need any operator between you and the CPU. So any human operator, but there is someone who we called the operating system, which tries to communicate with the hardware based on your needs. So this means this has given the chance for another person known as system administrator, which is a human, which is not doing those kind of things which were being used or done by the computer operator, as we discussed in the start in the history of operating system. However, they are obtaining and overseeing the installation. So there are new installation packages, they are doing that thing, they are issuing the new accounts to the organization, they are establishing mass storage space limits for each user. So for example, they are saying, okay, if our organization have 100 users, so we will give only 2 GB per user. So after 2 GB, user will not be able to save his or her data on the computer. So such kind of basically discretions or powers are vested in system administrator. However, they are not operating the machines in hands-on manner like the one the computer operator was performing for switching, for example, making the switches on or off, and then mounting the magnetic tapes, and then using other activities of punch card reading, etc. So such kind of activities have been taken from the human operator, and those were given to the operating system. However, some other activities are now performed by a computer operator, which is known as nowadays system administrator. And almost every organization have system administrator, and some organizations have a large department which is led by the system administrator, and then there are some other people who are working under system administrator. So OS has evolved from simple programs that execute only one job at one time to very complex operating systems which nowadays are fulfilling the time sharing, multi-programming, multitasking kind of things, and memory management as well. So such things we are going to discuss in next modules as well. So this evolution further continued So we have provide time sharing, multitasking, multi-programming, but such things were only performed to one CPU. So those were done for one processor. However, nowadays we have multiple processors. So for example, if 30 users can be serviced on one CPU, and if we have 10 CPUs, this means, and those are forming the same computer, so this means 30 multiplied by 10, which means 300 users could be serviced from the same computer. And in Pakistan, there are some computers available which have more than thousands of processors available within them, and those are called supercomputers. So when such multiple processors are involved in such basically execution, then there is another important term known as load balancing. So this dynamically allocates tasks to different processors. So for example, as I mentioned, if there are 1000 processors, so some of them are idle, which means they are not doing any work, and some of them are busy. So if new job is coming, so then that job is going to be assigned to those processors who are in idle stage. Or if all of them are busy and some processors are doing very extensive work, so those extensive parts should be divided into small parts, and small parts should be given equally distributed to all of the processors which you have in your computer. So such a term is known as load balancing. And then in load balancing, we also learn about scaling, which means you are breaking tasks into number of subtasks compatible with the computer, a number of processors available. So there are whatever you achieve in the load balancing by dividing the equal amount of time or equal amount of workload to each computer. So such basically a small task, and breaking of those small tasks into small subtasks is known as scaling. And then all of these kind of things were for only one computer, which means that computer may have multiple processors, but all of them are residing on physically at one place. Then this operating system has extended in terms of computer networks, which means that there are machines on the network which are available physically at different places, and they are trying to solve the same or execute the same problem which is given to them by load balancing and scaling. So this means that computer networks are then helpful of managing resources across many machines and many users rather than isolated computers. And then there is another important concept known as embedded systems. So there are different machines like medical devices, vehicle electronics, home appliances, you have microwave ovens at your homes, and all of such things have embedded operating system and their application software which is embedded within the device. So this means that you don't need to execute such a application on an isolated computer. Instead, that need to be computed or executed on that particular device, and such a system is known as embedded system because it is embedded, it is built in, it is available within that particular hardware somewhere. And these conserve battery power and working continuously in real-time fashion because they need to provide the response in real time like medical devices. So if we summarize today's module, we have learned further basics of operating system. We have seen that the need of human expert has been overruled, and we are now using the system administrator, but that is not doing the hands-on machine working. And then we learned about load balancing, scaling, computer networks, and embedded systems.